Standard temperature, thank you Sandy, 273.15 Kelvin, and standard pressure, 1 atmosphere. All right, let's use this same equation here, that N equals PV over RT. Okay, what's the pressure? 1 atmosphere. What's the volume? 725 I got to convert that. That ain't going to work. 0.725. I didn't screw something up over here, didn't I? It was already in liters. Okay, this gas constant's in liters. You have to convert the liters here. All right, I just about screwed that up. 0.821 and 273.15. So what am I going to get here? This is going to be my number of moles of a gas. All right. 0.725 divided by 0.0821 divided by 273.15 equals 0.0323 moles of NH3. Yes? No? Yes? Okay. How do we go from moles to grams? Well, 1 mole of NH3 weighs what, 17, 14, 15, 16, 17 grams of NH3 from the periodic table. Nitrogen weighs 14. Each hydrogen weighs 1. 14 plus 3, 17. Times that 0.5496 grams of ammonia. All right. And it is certainly not unusual to have masses of gases in grams. All right? Because on the side of a big gas tank, it'll say the tare weight. So the tare weight may be 80 pounds, which means that's how much it weighs empty. And then when they put gas in it, it may weigh 300 pounds. So when you put it on the scale, you can start noticing when your tank's going to be empty. Does that make sense? All right. So obviously if you've got gas in a tank, it weighs more than if the gas is not in the tank. Did we get that one?
If you round to 0.55,
that'd be fine. And here I don't worry about rounding, right? You can tell I don't do it. Technically, probably the 725 is 3 sig figs, so the exact answer should be 0.550, right? All right.
So you always convert to liters?
Yes, because your gas constant's in liters. Last one's 48, right?
48. I did 38 too, but it says 40 on the I did it too.
Okay, 48. When glucose is burned, right, a combustion reaction, C6H12O6 plus 6O2 yields 6 CO2 plus 6 waters. They were nice. They give you the equation. How many liters of CO2, liters of this, can be produced from 1,500 grams of glucose in excess oxygen at STP? Are you a big STP fan? Really? Wow, that's exciting. Who else is an STP fan? Anybody?
I'm a big ATP fan.
An ATP?
I like ATP. Works good.
Wonderful. No one else likes STP? That was a big band when I was in school. Wow, only one person. Okay, 1,500 grams. Stone Temple Pilots, STP?
Oh, you're not with me?
Yeah. Duh. What do you think? I was talking about chemistry?
I was like, yeah.
Do that in here. All right. So 1 mole of C6H12O6 weighs 180 grams, right? Because I got to figure out how much I'm producing over here. So that's going to cancel. What's my ratio? So now let me rephrase the question. Do you like the band STP?
I don't think so.
You don't think? Oh, you don't know them. Okay, sorry. All right. So 6 moles of CO2, right? So who likes the band STP? All right, no one's ever heard the band Stone Temple Pilots. Wonderful. 1,500 divided by 180 times 6 equals 50 moles of CO2. Are you happy with that? Now, how can we convert from a mole to a liter? What do you want to do? Because it wants it in liters, not moles.
We went the long way around. Found out later that we could use 22.4.
All right. So this person here wants to use 22.4. 1 mole of CO2 is the same thing as 22.4 liters at STP. Are we at STP? So we can pathologically use that number. So 50 times 22.4 is going to be 1120 liters. 1,120 liters of CO2. Now what she's talking about is she says that what she done was as follows. She is looking for a volume, so that's going to be nRT all over P. The number of moles is 50, 0.0821, 273.15, 1. What's she going to get there? 1120. I really do recommend using this method. I mean, certainly it's a step longer than using 22.4, but you don't have to worry about it STP, because remember, on a test, all I have to do is to mess up your world and say you're at 280 degrees instead of 273.15, right? So if you were at 280, would this number work? No. You'd be forced to use this method. It's always a good thing. You know, as a physical chemist, I like methods that work all the time, right? Or at least all the time in a freshman class. I want a method that's going to work every time. I want to know what's going on, and just drop it. All right? Don't give me a number that works part-time here and part-time there. Then I got to worry about when that part-time is. All right, who made 100 on this test? No? Naturally, this is a little bit more complicated because we took the Chapter 9 stuff, tied it into the Chapter 12 stuff, right? We ready to go home? One person's ready to go home, Bonnie. And one person that said she actually enjoyed my class is ready to go home. All right, well, I'm done with you. That's it. Remember now, tomorrow, just to recap, test over Chapter 7, 8, 9, 12. Take that tomorrow, get out of here. We'll come back on Monday and start a conversation over 13 through 16. And then, do we have a final next week? A final the week after, so we have like 2 weeks of class left, right? And then 1 week of selected topics. Yes? I think 1 week it says in the syllabus is selected topics. What do you guys want to talk about? Like the next week is covered. I got that for you. But then, huh? What?
The selected topics you said what we do.
Mm-hmm.